Today we're going to solve quartic polynomials. And what we reinforced yesterday with our solving polynomials is that a quadratic has two roots because the highest power in a quadratic equation is 2. A cubic has 3 roots because the highest power in a cubic equation is 3. In a quartic, the degree is 4, which means today we're going to be looking for 4 roots or solutions because our highest power in a quartic is 4. But the process is going to be the same as yesterday. We need to ask ourselves when we're looking at these problems, can we factor? Because that's our most useful technique for solving these. And as we take a closer look at this one, the answer is yes. Our second question was, do we have a greatest common factor? And we don't have a greatest common factor, but we can factor. And because there are 1, 2, 3, 4 terms in this problem, let's try factoring by grouping. So here's a group, and here's a group. When we factor out the greatest common factor in the first group, what we see is the smallest exponent is a 3. We had 4 x's, we took out 3, we've got 1 left. And 3x cubed divided by x cubed is 3. We had 3 x's, we took them out. Over here in our second group, 27 happens to go into 81. 27x divided by 27 is x. 81 divided by 27 is 3. And what we see here is that we've got x plus 3 from both groups. Let's separate that. So we've got x plus 3. And then we have x cubed plus 27. The thing that we have to notice at this point is that we can still factor. And we need to keep factoring to finish this problem. Can't do anything with the x plus 3. But we can factor x cubed plus 27. And just a reminder that I'm going to use the SOAP as part of that. We're going to be factoring a cube. And when we factor a cube, the cubed root of x cubed is x. The cubed root of 27, which you could type into your calculator if you need to, ends up to be 3. And if we can get those values, I think we can get the rest. But SOAP, first of all, stands for, the S stands for same. We've got a plus in the original, so it's going to be the same. Same sign. Then the next sign that we put in the problem is going to be the opposite. O for opposite. And then AP is always positive. That will be our last sign. And now that we've got that, we're going to fill in this other parentheses here. We'll do that by taking x cubed divided by x, which is x squared. And the process still works. If we had 3 x's, we took out 1, we still have 2. Well, 27 divided by 3 is the next part that we're going to do. 27 is in the last position of our parentheses, and 3 is in the last position of our parentheses. So 27 divided by 3 is going to be in the last position of our parentheses. 27 divided by 3 is 9. And remember, we already have the signs in there, so we don't have to worry about that. So we're going to take x times 3 from our second parentheses listed here on the board, and x times 3 is 3x. Our signs are already in there. Ultimately, what we're trying to do is we're trying to find 4 solutions to this problem, and we're going to use these factored values to help us. We're going to take x plus 3. It's got to be equal to 0. And we're going to subtract 3 from both sides, and we get x equals -3. And to do the same thing here, and you may need to do it, and you might not need to do it. But we're looking for 4 solutions. And the first 2 are going to be the same value. When we solved it, we get -3 and -3. But remember, when we factor a cube, this trinomial, this 3-term expression, cannot be factored. So ultimately what we have to do is we have to say that A is 1, B is -3, and C is 9. And we're going to use the quadratic formula on this particular problem. We're going to fill it in. You can't see it on my screen, but you can see it on your paper. The x equals the opposite of B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. We filled in the quadratic formula. If you're using your calculator, make sure that you put parentheses around the -3. But we have a double negative to start here, and it's going to be positive. It's going to be positive 3 plus or minus -3 squared. That's where you really need the calculator. If you have to type it in, it's positive 9. Minus 4 times 1 times 9 is 36. Divided by 2. Well, we can get close to finishing now. 9 minus 36 is -27. Divided by 2. And we need to simplify that square root. This is the square root of -1 times the square root of 27. What does the square root of -1 equal? And it equals I. 27 is 9 times 3, which is 3 times 3. So what we're looking for is we're looking to simplify the square root of 27. So it's going to be 3 times 3 times 3. And we need 2 of the same value to take out 1. 2 of the same value to take out 1. Get 3, the square root of 3. But don't forget at the beginning, we took out that I. So when we put that back into our problem over here, we have x equals 3 plus or minus 3i radical 3 divided by 2. And just a reminder that what that means is, it means 3 plus 3i radical 3 over 2. And it means 3 minus 3i radical 3 over 2. And if you want to write them both out, write them both out. If you want to write plus or minus, write plus or minus. It doesn't make any difference. But one mechanism for checking whether you have something correct or not is, did you get 4 solutions? And when we come back here and we fill this in, the 3 plus the 3i radical 3 over 2, and the 3 minus the 3i radical 3 over 2 would be the third and the fourth solutions. Again, I don't think that any Algebra 2 teacher is going to have any issue with you typing or writing 3 plus or minus 3i radical 3 divided by 2. But if you're very literal, we say 4 solutions, -3 is a solution, -3 is a solution, the top green is a solution, and the bottom green is a solution. There's the 4. So when we look at these quartics, once again, we know we're looking for 4 solutions. That's what quartic is to the 4th degree. And we need to ask ourselves, can we factor? Well, y to the 4th minus 16. We can factor. It's actually the difference between 2 squares. So we're going to take the square root of y to the 4th. We get y squared. We're going to take the square root of 16, which is 4. And then it's the difference between 2 squares, so it's different signs. And in fact, at this point here, we can factor some more. And it's actually the first parentheses that I have written that can be factored some more, because it's y squared minus 4. Difference means the answer to a subtraction problem, so we can only factor the subtracted part. But the process is still going to be the same. Y squared. The square root of y squared is what? Square root of 4 is 2. And difference between two squares, different signs. And this factoring process here is going to allow us to get all 4 roots of our quartic when we set each of them equal to 0. Y minus 2 equal to 0. Some of you don't need to set it equal to 0. You can go right to the answer. The y plus 2 equal to 0. And then the y squared plus 4 equal to 0. And when we simplify this, we'll add 2 to both sides. So we get y equals 2. We'll subtract 2 from both sides. We get y equals negative 2. And on our third one, we have to do a little bit more work, but we're going to subtract 4 from both sides. We get y squared equals negative 4. And we need to undo the squaring. Undo the squaring, we take the square root. We end up with y equals, well, this is the square root of negative 1 times square root of 4. And the square root of negative 1 is I. Square root of 4 is 2. 2i. But because we took the square root, we need to take into account that it could be positive or it could be negative. Positive times positive is positive. But negative times negative is still positive. So those are our 4 roots. I will write them each individually up there. Fine with you writing the plus or minus. So when we go back and fill in our answers here, we've got 2, negative 2, 2i, and negative 2i. And there are our 4 roots, our solutions, our x-intercepts, our zeros of the function, if you prefer. But as we finish, again, when we're solving quartics, and it would even work on quintics as well, we have to ask ourselves, can we factor? And on this particular problem, we have to assume that the answer is yes. We do not have a greatest common factor. But we do also have 3 terms. 4x to the 4th is a term, 13x squared is a term, and 9 is a term. So we're going to try to split the middle on this one, and we're not going to try. We are going to be able to split the middle in this particular problem. So we're going to take 4 times 9, it's 36. We are looking to find 4 solutions, before I forget that. And 36 is 1 times 36. 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And we're looking, can we combine to be 13? Well, 4 and 9 will combine to be 13. And even more specifically, negative 4 and negative 9. Again, splitting the middle. Got 4x to the 4th here and the 9 here. And when we fill it in, it's going to be minus 4x squared. So whatever's in the middle, we need to keep that term there. Minus 9x squared. And then we're going to go back to grouping. So here's a group, and here's a group. And we're finding the greatest common factor in these groups. And in our first group, we see that both terms have a 4 in them. And then it's going to be the lowest x term. So our greatest common factor is 4x squared. And when we factor that out, we're left with x squared minus 1. And yes, we have to write the 1. We had 4 x's. We took out 2. We still have 2. 4x squared divided by 4x squared is 1. And we should end up with the same value in our parentheses over here in our next one. Our greatest common factor is a 9. 9x squared, negative 9x squared divided by negative 9 is x squared. Positive 9 divided by negative 9 is negative 1. And what we see is we've got x squared minus 1, x squared minus 1 in each group. So we have x squared minus 1, times 4x squared times 9. We stop and we take a look at this a little bit more closely, and the thing is, we can still factor both of them this time, because they're both the difference of squares. So x squared minus 1, well, x squared is x times x. 1 is 1 times 1. Different signs. The same process here with the 4x squared. Square root of 4x squared is 2x. Square root of 9 is 3. Difference between two squares, different signs. And now that we have it all factored, we can come up with our 4 solutions. Some of you don't need to write all the steps that I'm going to write. It's x minus 1 equals 0. And we add 1 to both sides. And get x equals 1. X plus 1 equals 0. We subtract 1 from both sides and get x equals negative 1. 2x minus 3 equals 0. We add 3 to both sides and get 2x equals 3. And divide both sides by 2. So x equals 3 halves. And as I'm looking at my space here, 2x plus 3 equals 0. Subtract 3. We'll get 2x equals negative 3. And divide both sides by 2. So x equals negative 3 halves. We're solving a quartic. We're looking for 4 roots. And they're all right there. 1, negative 1, 3 halves, negative 3 halves. And that's what we'll finish with on our blanks here. 1, negative 1, 3 halves, negative 3 halves.